to the Journey Chez Chem. Well, today you have a little more practice on balancing redox reactions in acidic solution. So please do the best you can, and I'll see you in a moment. In balancing this complete redox reaction, you might have noticed that we only had one compound to begin with, and oftentimes students are just totally confused about that. I bet you weren't quite so confused. Well, in this case, it does both things. Well, our bromine is a diatomic molecule here, and therefore it has an overall charge of 0. This bromine is -1 as shown by its ion. Now, here, oxygen is -2. There are 4 of them, which gives me a -8 on the oxygen, and the overall charge of this polyatomic ion is -1. I know you're familiar. Remember the penguin sheet? So in this case, bromine is +7. So what has happened here, and oxygen is -2, what has happened here is that this bromine, in this case, it has gained 1 electron. It was reduced. And then it also lost 7 electrons and was oxidized. And it's very possible that a compound, whether it's a reactant or a product, can do 2 things. And this is to give you some experience with that. Then I break it up into the half reactions. Well, bromine is going to bromide. And I need to notice that I have 2 here, therefore I must have 2 atoms on the other side. So I gained not just 1, but 2 electrons. And I must add those 2 electrons in. And I must balance those number of electrons so that the charge is the same on both sides of the equation. Then bromine is also going to perbromate. And I notice that I must also make them to be 2 of them because I have 2 bromines here, and each individual half reaction is handled independently. Now I'm going to add that I lost not just 7 electrons for 1 atom, because when I do these brackets it's always for a single atom, but I have 2 atoms, and therefore I lost a total of 14 electrons. And because I have oxygens here, I'm going to have to balance those. And I know that in an acidic solution, I'm only allowed to add hydrogen ions, which makes it acidic, water, and electrons. That's all I'm allowed to add. Only these players are allowed on the court. So remember that. Very important. Okay, so we have to then add 8 waters to get these 8 oxygens. And then I need 16 hydrogen ions. And then that half reaction is balanced. Before I can add them back together, I must have the same number of electrons gained as there are lost. And therefore, I am going to multiply this one by 7 to get there to be 14 electrons gained and lost. And therefore I have 14 electrons, 7 bromines, and 14 bromide ions. And then I just go ahead and my electrons will cancel and nothing else cancels, so I can just go ahead and add them together. I have 8 waters, and 7 plus 1 gives me a total of 8 bromines. And I have 14 bromide ions, and 2 perbromates, and 16 hydrogen ions. Now, you'll notice that this is divisible by 2. All of these coefficients are divisible by 2. And I have to always put it in the lowest ratio possibility, and I'm going to divide them all by 2. And therefore, I get 4 waters, and 4 bromines, and 7 bromide ions, and perbromate ion, and 8 hydrogen ions. And that is my final answer. And then in number 2, I'm going to answer that in a moment. I'll be right back. In number 2, I'm going to go ahead and use the abbreviations that you're given on the worksheet so that we become more and more familiar with those abbreviations. Well, OA stands for oxidizing agent. And by definition, the oxidizing agent contains the element reduced. Those two opposite things go together. And when I see that my bromine here is reduced, then it would be bromine. And Br2 is the compound that contains the element reduced. My Ra contains the element oxidized, and the element oxidized again is bromine, and bromine, the diatomic molecule, is my reducing agent as well. It acts as both the oxidizing and the reducing agent. Then in the half reaction of oxidation was a total of 14 electrons. In the reduction half, there were 2 electrons, and a total of 14 electrons are being transferred in this reaction. Now you have 8 more to do this evening, and also you have a quiz. Remember, the quiz is only half reactions. You should be really good at that. However, I do urge you to review the material on worksheet A. I know you do well. So there you have it, balancing redox reactions in an acidic solution. And I can't wait to see you tomorrow. Bye.